Picking up right where we left off, let's talk about calculating probability. The probability of event A is always a value between 0 and 1. And if you think about, okay, probability, we're thinking of like the decimal form of a number. And it makes sense then that it would always have to be a value between 0 and 1, because if you thought of the percentages, that would be like, well, it's somewhere between 0% and 100%. Likelihood of an event could be 0% and it could be 100%, but it's probably somewhere in the middle. Okay, and even kind of in their parentheses, 0 means the event cannot occur, because 0 would be 0%, and 1 means the event is certain to occur. It's guaranteed, right? 100% likelihood. Also, the sum of the probabilities of all outcomes in the sample space is 1. If you add up all possibilities in the sample space, then all those probabilities would add to exactly 1, because, well, something in that sample space has to occur. Okay, so how do we actually do this? Well, you see a formula there with a big fraction. So the probability, there's some notation here as well. The probability of event A, we denote as capital P with A in parentheses, and we read that as P of A, or you might even say, just say the words, the probability of A. Let me write that out here. The probability of A, or the probability of event A. Okay. And it's equal to the number of ways that A can occur divided by the total number of ways. Okay, now we're thinking the number of ways that A can occur. How many outcomes are in event A? And when we divide by the total number of outcomes, we're thinking the total number of outcomes in the sample space. Okay. In this formula, all outcomes are assumed to be equally likely, as in rolling a die. And that's kind of an interesting point to make. And that really goes for this entire chapter. All of the outcomes are equally likely. So every card in the deck is equally likely to be drawn as any of the others. Rolling a die, if you roll a die, you're equally likely to get any one of the 6 faces as any of the others. Here's the thing, though. When we take this into statistics, that statement's not going to be true. All outcomes are not equally likely when we go into, maybe more day-to-day examples. That doesn't mean that these ideas are not going to carry over. To a large degree, they will, but that equally likely stuff is not going to carry over into more typical statistics examples. Okay, anyway. For now, let's get on to practice number 2. Calculate the probability of the event. Write as both a fraction and as a decimal. We'll just practice both of those. And the decimal we're going to round to 3 places. So several of these here, and we've got some, drawing card, rolling a die, family, that sort of thing. So part A there, drawing a red ace from a deck of 52 cards. Okay, let's think about this. So we're going back to the deck of 52 cards, drawing a red ace. Now here, I'm going to think of event A as a red ace. And I'm just using the words red ace just as kind of a shorthand. This is just to remind myself of what I mean when I say event A. Okay, so if this was a formal question like what is event A, then we're not allowed to just write like a description like red ace. We have to draw, there's a red diamond and a red heart, and we'd have to draw those. Or at least write that, red diamond, comma, red heart. But just here, I'm just trying to kind of say this to myself to kind of remind myself what event A means and kind of identify it. Okay, so we're going to draw a red ace from a deck of 52. So we'll think, okay, going back to the formula, how many red aces are there? And if you're familiar with the deck of cards, then you probably know it right away. If you're not, you can go back to the drawing at the top of the lecture. There are two, and I said them a moment ago. There's the red heart and there's the red diamond. So there are two red aces. And we'll divide that by the total number of outcomes. Well, there are 52 total cards. So the probability of this event A is 2 out of 52. That's the fraction, but we can reduce that. We could reduce 2 out of 52 to be 1 over 26 if we divide them both by 2. Get the reduced fraction. So there's the fraction answer. And if we put that into a calculator, and I believe that very confident that needs to be rounded, we would get this decimal to 3 places, 0.038. And so there's your decimal version. Which, if you thought about the percentage, right, that'd be 3.8% to get a red ace. Pretty low. You know, there's only 2 out of 52. Makes sense. Okay, let's go on to part B. A single die is rolled, and the number is less than 9. Okay, let's think about this. So they roll, and when we say a single die, we mean just your standard 6-sided die. And the number that we see is less than a 9. Well, okay. I think I wrote event A again. Okay, we get a value less than 9. Well, out of all of the 6 sides, how many of them are less than 9? You think, well, all of them are, because they just have the numbers 1, 2, 3, 4, 5, and 6. All of those are less than 9. So it turns out this one is going to be guaranteed to happen. The probability of this event A, the number of ways that this can occur, is 6. 6 out of 6. The total number of ways is 6. So 6 divided by 6 is 1. And, well, here, we think 1, that represents 100%, but we're going to keep it at just as 1 to be the probability. And now this really is both a fraction and a decimal. 1 is the fraction, and so we just have the one answer here. Okay, moving along. Part C, going to the family. In a family of 3 children, exactly 2 are girls. I told you guys that's my family. I have 2 girls and 1 boy. Girl, girl, boy. What is the probability of that happening? In a family of 3, that exactly 2 would end up being girls. Now here, any 2 could be girls, and the boy could be, whichever one. Here, maybe it's helpful just to go back to our practice number 1. So here was the family of 3. So we see the sample space. Maybe how many are there in the total sample space? There are 8, right? So there are 8 total ways to have a family of 3. How many of them have exactly 2 girls, right? That's our event. Well, it's these, isn't it? Exactly 2 girls in each. We would not count girl, girl, girl because we want exactly 2 girls. Okay. So there's 3 ways out of a total of 8. Exactly 2 girls. The probability of that, probability of A, 3 out of 8. There's our fraction. It's already reduced, and we got the decimal form there. And that did not have to be rounded. It's exactly 0.375. Okay. And part D, when a die is rolled 2 times, the first number is 3, and the second is even. All right, so we're going back to the die roll, but now we're taking that one die, and we're going to roll it once, and then we're going to pick it up again and roll it a second time. And we're thinking, all right, the first time we roll, we get a 3. The second time we roll, we get an even. Okay, now this one, when there's multiple components to do a probability, we have to be a little bit careful. So let's set this up. We can sort of describe event A like this. We get a 3 first, comma, even. So let's think this through, and I'll just show you my work here and then talk us through it. So the probability of A. If you have two components like this, we look at the probability of each one and we multiply them. Okay, so the probability of rolling a 3. Well, how many 3s are on a 6-sided die? Just one, right? There's one side that has a 3 on it. And there are 6 total sides. So the chances of rolling a 3 are 1 out of 6. Okay, then we're going to pick up our die and roll it a second time. And this time we're hoping to get an even number. And so what are the chances of getting an even number? Well, how many even numbers are there? Well, there's the 2, the 4, and the 6. Right? So that's 3 possibilities, 2, 4, 6, out of a total of 6. So 3 out of 6. And when we have those multiple components, we multiply them. I'm not going to go into why it is we multiply here. And just from teaching this course in the past, I think that's the best approach. However, if you are curious why we multiply these, stick around for an office hours one day and or email me or something like that, and I can break it down for you. Why is it that when there's multiple components, we multiply the two individual probabilities? And I think it's better explained that way for those interested. Okay, so to finish off the problem, we're going to multiply these fractions. And so you could grab a calculator. Maybe if you remember how fractions multiply, we multiply the numerators 1 times 3. And we multiply the denominators 6 times 6. And that's our new denominator. 3 out of 36. That can be reduced to 1 over 12. So there's our reduced fraction. And there's the decimal form having been rounded, 0.083. Okay. So rolling a 3 and then picking up and rolling an even, not very likely to occur. Not even 10%, 8.3% chance of that happening. And maybe you'd expect that. Makes sense. I got that one last sentence down below. As in the last example, the one we just did, part D, to find the probability that several independent events all occur in order, take the product of their individual probabilities. And that's what I just explained. Look at each probability on its own and then multiply them. Okay, let's stop this video here. More to come.